Okay, part of this we're going to do today, and part of it we're going to do tomorrow. Today we're going to practice something that you should have done before. This is one of those rare times in trigonometry where this will look somewhat familiar. Right triangle trigonometry means we are not in the unit circle. And so what that means is if we're not in the unit circle, that means that the radius is not necessarily equal to 1. And so if the radius is not equal to 1, it could be anything else. In fact, we don't even talk about the radius. We talk about different sides. Suppose that this is the angle theta right here. Then we have 3 sides of the triangle that we like to talk about. Number 1, this works with a right triangle, and we call this side the hypotenuse. Does anybody remember the other 2 sides? The legs adjacent and opposite. So what does adjacent mean? Does anybody know? They share the same side, exactly. So, for example, Miss Nelson's room is adjacent to my room. Yes? Mr. Fiskus's room is not adjacent to my room. Okay, so the side that is shared with the angle other than the hypotenuse is the adjacent side. Now, if you look right across from the angle is made up of those 2 sides, correct? The other side that does not make up the angle is called the opposite side. We can also think of these things in terms of y, r, or x, and r. So, sine of theta. Instead of calling it y over r, we call it opposite over hypotenuse. Cosine, instead of x over r, we call it adjacent over hypotenuse. And tangent, we call it opposite over adjacent. There's an acronym that goes together to help you understand how to remember this. And the acronym goes like this. So, ka, hoa. I want you to know that I never learned this acronym while I was in high school. I always remembered it by X, Y, and R, and that was it. Okay. So this means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. So there we have it. Cosecant, secant, and cotangent, you will not use those. You will not use those when solving right triangles, so we don't even need to worry about them. Don't put an X through it in case we make notes there later for something else, but we don't need to worry about that. From those, we can then generate some other trig identities, but we're going to get to that at a different time. The part that we're going to focus today on your assignment is something that people generally really like regarding trigonometry, okay? We're going to do example 1 and a couple solving for other triangles, okay? It says, find the exact value of the 6 trigonometric functions for theta, given the legs of the triangle are 15 and 7. So I'm going to put theta there. Theta should be given to you in the problem. It shouldn't be left blank. We'll say this is 15, and I'm sorry, instead of 7, we're going to call it 8. Works out much nicer. Okay, what other value do I need to find in order to write these six? The hypotenuse. How do I find the hypotenuse? I use the Pythagorean theorem. Pythagorean theorem says a squared plus b squared is equal to c squared. Take a and square it, 225. Does it matter what I call a, whether I call it 8 or 15? It doesn't matter. So 225 plus what is b squared? 64 is equal to c squared. 225 plus 64, 89 is c squared. How do I solve? Square root and you get 17. So in terms of opposite, adjacent, and hypotenuse, what is sine? Opposite over hypotenuse. What is the opposite side? 8. What is the hypotenuse? 17. So sine of theta is 8 over 17. What is cosine in terms of opposite, adjacent, and hypotenuse? Adjacent over hypotenuse. So it is 15 over 17. Tangent is opposite over adjacent, so 8 over 15. And if we did list the other three, we simply take the reciprocal. What's the reciprocal of 8 over 17? And you've got the idea all the way down here. It's no big deal. Those are the other three. So if I give you two sides, could you find the third and list them? Good. Now, let's move down to example 4. And I need you to fill this in. We're going to make this a right angle, this a right angle, and this a right angle. And we're going to call this theta. We're going to call this theta. We're going to call this theta. And then I'm going to give you some values. We're going to call this, oh, theta is 32 degrees. Theta is 64 degrees. Theta is 49 degrees. Say that side's 9. And we are going to look for x. We're going to say this side is 10. And we are going to look for x. And we're going to say this side is 24. And we're going to look for x. Okay, do you have the drawings filled in? Okay, so what right triangle trig allows us to do is instead of having two sides of a right triangle and use the Pythagorean theorem, we can have one side in an angle and still solve for it. So look at what I'm going to do. I want to find x by using right triangle trig. And I'm just going to dot the angle right here so we can understand. I first have to make a choice whether I'm going to use sine, cosine, or tangent to solve this problem. Now, first, what is x? Is x the hypotenuse, the opposite, or the adjacent? Hypotenuse. What is 9? The opposite, hypotenuse, or the adjacent? Opposite. And so the other side is the adjacent that I'm not really concerned about. So once you identify the side you're trying to find and the side that you have, I can use that to identify which of the three trigonometric ratios I'm going to use. Why use sine, cosine, or tangent for this? I will use sine because sine is opposite over hypotenuse. So I set up a ratio. the sine of my angle, 32 degrees, over 1 is equal to what? Give me a ratio for what it's equal to. 9 over x. Now, I'm going to cross multiply to solve for this. I will take x times the sine of 32. X times the sine of 32 is equal to 9. How would I then solve for x? Divide by the sine of 32. Divide both sides by the sine of 32 degrees. So x is 9 over the sine of 32 degrees. So I'm going to calculate that on my calculator. So take out your calculator and make sure that you're working in, are we working in radians or degrees? Right? No. We are working in degrees. You could. I think, if I'm following you right. On the ACT, they will often leave the answer in this form right here. So instead of giving you a decimal, they'll say 9 over the sine of 32. So as I turn my calculator on, I go into mode, and this is the first thing you'll do incorrectly. You'll get wrong answers. And you'll say, Mr. Gens, why am I getting wrong answers? Why are my answers not matching up with the answer key? And I'll tell you, it's because you're probably not working in degrees. You're probably sitting in radians. You have to be able to check that. And so we'll take 9 and divide it by the sine of 32 and close my parentheses, and I get 16.98. We'll round to 2 decimal places. So x is 16.98. Look at my original problem, folks. Does it make sense that this side, 16.98, would be longer than 9? Yes, it does. Any questions there? Does that look all right? Okay, let's try the next one. Again, I will outline my angle right here. What side is 10? Opposite, adjacent, or hypotenuse? Adjacent. What side is x? Opposite. Which of the 3 trigonometric ratios has to do with opposite and adjacent? Tangent. So I set up the tangent of what? 64 degrees over 1 is equal to what? X over 10. I cross multiply. X times 1 is x equals 10 times the tangent of 64. I do this to show you that you don't always divide. Sometimes you end up multiplying. Here we did 9 divided by the sine of 32. Here you do 10 times the tangent of 64. You can't just say, oh, well, I don't have to go through the work of setting it up. I'm just going to do whatever. It doesn't work like that, folks. So we got 10 times the tangent of 64. And I'll round to 2 decimal places, 20.50. You see if you can do the last one on your own. Go. Okay, I will be clear. This skill, you know how last week we made the circles, we found the terminal points, and we found the exact values? That's a fundamental skill. You can't leave trigonometry without knowing how to do that. This is the other one. You have to be able to solve right triangles. So we're going to take our time with it, but this is the process we set up every time. I make my angle, okay? What's 24? Which side is that? Hypotenuse. What side is x? Adjacent. So you could see that this is the opposite one. So now that I've identified those, which is the ratio that I use? Sine, cosine, or tangent? Cosine of my angle, 49 degrees, over 1 is equal to adjacent over hypotenuse, which is x over 24. Cross multiply, x is 24 times the cosine of 49. When you take 24 cosine of 49 on your calculator, you do get 15.75 if you round it. Okay, I'm going to hand out our worksheet, and we're going to start practicing our assignments. But we need a little practice yet. Okay, folks, you don't know how to do this yet. I'm going to teach you something new that's part of your worksheet. This is another skill that you need to know how to do, okay? So I have problem 1 here, and it says that you have a right triangle, and this time you're not given an angle, and that's okay. I'm going to show you something new that you can do on your calculator, okay? So first of all, can you tell me if it's sine, cosine, or tangent? This time I'm given 2 sides. Which side is this? This is the hypotenuse. It is a, no, it's okay. So here's how we tell. It's across from the biggest angle. So it's the largest side. So that's the hypotenuse. That would make this adjacent. So sine, cosine, or tangent? Cosine. Pay very close attention. This is different. Do we know the angle? So we write theta. What's the ratio? 12 over 13. This is really cool. The mathematics behind this working is pretty substantial. Involves some calculus. But what we do is we need to now get the angle. When you need to find an angle, you don't press sine, cosine, or tangent. You press second sine or second cosine or second tangent. It's sine inverse, cosine inverse, tangent inverse. That's what that -1 means. It means inverse. So I want to see what the angle is. So I go second cosine, and I type in 12 over 13. And I get 22.62. That means that the angle there is 22.62 degrees. Or you got the super duper special calculator. Oh, we'll have to figure something out. I don't know. Once again, folks, if you do want a calculator that has great scientific options on it, in fact, when I did calculus, I preferred my graphing calculator, but when I took all my other courses in high school, I preferred the little $6.99 Casio calculator that has 285 options on it, very similar to what Eric has right now. It's the Walmart version for, again, $6.99. It's an awesome calculator, and it does these operations very quickly for you, and there's tons of them on there. So not a big fan of Texas Instruments other than the graphing calculator. The other Texas Instruments calculators, not a big fan of, not a big fan of it all. So yeah, the TI-80, the graphing calculators, those are nice. But I would much rather, personally, I would much rather use a Casio than this one. This one has a limited number of options, and I think that they're bulky. So no. If you have a TI 30, go ahead, use it. It's just fine. But the BA ones, the business analysis ones or whatever they are, those have a lot of things that are non-scientific on there. So, okay. Number 2. What's that? That's all you have to do. Number 2, find the missing angle. So I want to find theta. You tell me. I'm going to mark out my sides. What side is 13? That's the adjacent side. What side is 4? Opposite. So which of my trig functions do I use? So I say the tangent of theta is equal to, what's the ratio? 4 over 13. You go ahead, see if you can do the operation now to come up with the angle, okay? I'm going to give you 20 seconds here, see if you can use your calculator to come up with the angle. All right, is this what you came up with? No, tell me why. I didn't do second tan, I just pressed tan. So if you press second tan, see the difference? You have to make sure you do that. 4 divided by 13. And I get 17.10. That okay? Okay, move down to 9 and 10. Just fine. So for 3, 4, 5, 6, 7, and 8, all you're going to do is find theta. Okay. For 9 and 10, a little bit different. We'll do 2 of those together. Okay, here we go. All right, let's look at number 9. Now I just want to find x. So we practice this. Let's put it into work here and see what we can get. Make my angle right here. What side is x? It's like this is the 90-degree angle here, so not the hypotenuse. What side is 11? Or did I say what side is x? Oh, sorry. Yep, hypotenuse, good. And what side is 11? Adjacent. So which of the 3 have to do with adjacent and hypotenuse? Cosine of what? 37 degrees is equal to, what's my ratio? 11 over x. How do I solve? Cross multiply. So x times the cosine of 37 degrees is equal to what? 11. Now I divide by that cosine of 37. 11 over the cosine of 37 degrees. And I can solve for that using my graphing calculator. 11 divided by cosine of 37. Whoop, yes, sorry, thank you. Yep, we don't need that degree sign because this is a length, not an angle. And then finally, number 10, I'm going to outline my angle. Okay. What side is 13? Adjacent. What side is x? Opposite. Okay. Sine, cosine, or tangent? Tangent. Tangent of what? Tangent 32 degrees equal to what? X over 13. How do I solve? Cross multiply. X equals 13 tan of 32 degrees. Take out my calculator. 13 tan of 32. I get 8.12. So we are going to work on 17, 18, 19, 20, 21, 22. We're going to work on those tomorrow. Right now, your assignment is just to complete the 1 through the 16 part. And so that gives you about 14 minutes, and you very well might get it done. So go ahead and get to work. So what's that? The last 8, 17 through 24, that's what we're going to work on tomorrow.